Hello. Good morning. Am I on? I'm on. Get the recording going. Good morning, everyone. Welcome to the next big thing, defense or the Consumer Metaverse meets Defense panel. My name is Danny Williams. I am from Epic Games. I'm really excited to be here this morning. We've got a great panel of speakers that are going to be sharing some of their thoughts, insights, lessons learned from their respective fields and organizations about what the metaverse is, where it's going, how it's growing. So I'm really excited to have them here. I'm really excited to have all of you here. I want to take a quick second before we get started to thank the sponsors of this event. ITSEC and events like this at ITSEC aren't possible without these sponsors. So please take a quick second. Let's give a round of applause to the various sponsors we have for this event. We appreciate it. So our topic today is the consumer metaverse meets defense. Our goal with this conversation, with this talk this morning, is to gain some insights on where we are at this foundational moment of the development of the metaverse. And I think it's important as we do this, as we talk about this, a lot of talk about the metaverse these days, a lot of talk about what we're doing on the defense side, on the simulation and training side as it relates to the metaverse. And part of this panel, part of this talk, is to focus on what is the consumer market doing and how are things happening on that side of the industry affecting and what lessons can we learn from that. And so our panelists today have great stories, great experience on the consumer side of that market, as well as lessons learned that they've brought over to the defense industry. And so we'll have some great insights there. As I said, I work for Epic Games. The topic of the metaverse comes up quite often at Epic. I frequently get asked what I think the definition of the metaverse is. And I frequently say I have no idea, which is maybe not the best answer to give for somebody moderating a panel about the metaverse. But I think it's important to understand that we are at this foundational stage. I like to think about it through the lens of how the internet started. And if you think back to the organizations, the engineers, the industries that were fundamental in building what the internet has become, if they, at that point, were talking about what the internet would be, they wouldn't have known about Zoom or TikTok or YouTube or cat videos or any of the other things that we have all built, our various organizations and industries have built on top of that foundational capability that they started way back when. And so I think we are at a similar point in our time with the development of the metaverse in terms of building these foundational technologies. And so I think it's important to think about it from that perspective. I think 20 years from now, we'll all be looking back on this time and going, wow, we had no idea this is where the metaverse would go. So I think it's a great place to be. I think it's a very interesting place to be. And I think it's really great, again, from our side, a lot of us here at this show are focused on the military domain, focused on that industry. And it's important for us as an organization, as an industry, to make sure that we're looking at the broad aperture of what's happening everywhere with the metaverse, on the defense side, but also on the consumer side. Gaining those insights, gaining those lessons learned, and understanding what we are building, the foundational software, the foundational standards, the hardware form factors, all of those foundational pieces that are going to be fundamental to what the metaverse will become and what future generations will be able to build on top of. So that's very much where I see, if that's a definition of the metaverse, maybe it's not a great one, but that's where I see where we are as an industry. Again, I think it's great to have the group of gentlemen that we will be bringing up on stage here to share some of their insights on where some of these initial concept development, initial capabilities, initial technologies are being formed, stories and lessons learned that they have. And then again, how can we take those back to our companies, to our industry, and most importantly, back to soldiers who, at the end of the day, is why we are all here, is what can we do to better enable and empower soldiers to get the best training that they can. And that should be where our focus is. How can we leverage these lessons learned to help them, to help build whatever the military metaverse might become, help them in being able to do that and utilize it as best they can. So, very excited to get started here. Again, we have three panelists. They're each going to come up and go through their presentation. At the end of that, I'm going to invite them all back up on stage and we'll do a Q&A. So please get your questions thinking as we go through here, and we'll open that up at the end of the discussion. A couple of last quick logistics things. Please stick around at the end of the event. We've got a couple of next big thing talks happening today. And at the end of the day today, we have a social happening at 5:30. Before you leave the room, make sure you grab a ticket, either from myself or from some of the other organizers. You'll need that ticket if you want to come to the social. But that's going to be a great opportunity for you to, if you don't get a question in at the end of our talk today, an opportunity for you to come meet the speakers both from this panel, but also the other panels that are happening later today. So please join us for that at 5:30 in this general area. It's going to be happening over here at the end of the day today. So without further ado, I want to welcome up our first speaker. Black Shark AI is a company doing some very innovative, very interesting things on the consumer side, but that has also had some amazing work taking that knowledge, those lessons learned, into the defense realm. So please join me in welcoming Gustavo to the stage. There you go.
Thank you. Thank you, Danny. Good morning, everybody. Great to be here with you. My name is Gaston de Figueiredo. Don't worry about the spelling. It's actually encryption. Can't steal your ID if you can't spell it. My parents were forward-thinking people. So anyways, I am responsible for partnerships and public sector at blackshark.ai. We are a roughly 2-year-old company, but our origins are in the gaming industry. We started life as a gaming studio that developed the technology that you see in Microsoft's Flight Simulator 2020. So if you've played that game, you can fly all around the world with beautiful photorealistic reconstructions of cities and airports all around the globe. And we developed the technology to do this at planet scale. Everything you see in the scene behind, in the screens there, was actually generated by AI. So our technology evolved from a consumer perspective, and one of the ahas that the founders had is, wait a minute, there's more to this technology than just gaming. This can be used in a variety of applications. And so Black Shark was incorporated with the focus of bringing this capability across a variety of industries. Our mission statement is we work with companies and governments to empower people to solve some of the world's toughest challenges. And I'll talk a little bit about how that has anything to do with the M word, the metaverse, right? As a venture-backed company, we love the word metaverse because it instantly adds a lot of valuation, and venture capitalists are excited about that. But let's unpack that a little bit in this conversation. So we start from aerial or satellite imagery or drone capture. In this case, you're looking at an aerial picture that our partners from Vexcel Imaging collected. We then apply our AI algorithms at scale. We detect things that are on the surface of the planet, buildings, what shape they have, what is their geographical location, what is the characteristic of the footprint, and then we also detect things like the height, the roof shape, what is on the rooftop. Depending on the resolution of what is captured, we can even determine what objects are on top of the roof. And then we also look at things like vegetation, roads, water bodies. That information by itself is available and could be consumed by applications, by systems that need this from a geospatial perspective. As a matter of fact, we call ourselves the Geospatial Metaverse Company. But everything that you see here was captured from a look from above. We had no ground level information. And the reason we do this is because satellite imaging is the most pervasive data set about the planet. So we had to develop the capability to process satellite imagery, but also create a realistic looking environment. And so our strategy was based on starting from this data set, enrich it with what we call a geotypical reconstruction. So we apply generative AI beyond what we've already detected to create realistic looking facades. Remember, we had no ground level information. And so we devised a patented approach that allows us to describe recipes for what buildings look like in different parts of the world. And then AI applies the right recipe to the right building based on the geographical location. So buildings, single-family homes in Southern California versus South Florida versus Western Europe or the Southeast Asia. The algorithm will automatically select the correct rendition of that building, or high rises or commercial buildings and so on. And that's the technology that we brought to bear inside Flight Simulator that we now partner with several other companies to bring into what we call serious gaming, modeling, exercise, and simulation, but also in applications like we have an energy company that is using this technology right now to do site scouting, where they can deploy wind turbines and solar panels. So let's talk a little bit about the modeling and simulation side of things. We recently started a global partnership with Maxar Technologies, the leading satellite provider in the world. And so we've been working with Maxar in processing multiple petabytes of data in a single day and generating a constantly refreshable version of the planet. So think about it as a synthetic 3D implementation of every building and every part of the globe. So if, by the way, pop quiz, how many buildings are there on planet Earth? 1.5 billion is the number. So if you want to impress your friends on trivia, there you have it. So we've processed all of these 1.5 billion buildings, and we continue to ingest data and process it. And we then work and partner with companies like Epic to create a high-performant environment in which you can develop a simulation for multiple purposes. So as you can see, we're going to go on a little aerial tour of New Orleans. We've recently shown this at Epic's Unreal Fest in New Orleans. So we ran a reconstruction of the city, and you're going to see that yeah, it does look like New Orleans, and we are capable of adding specific landmark buildings. You'll see the Superdome we just flew over. That is obviously not a trivial process to detect via AI what the shape of the actual Superdome looks like. AI will see just a circle from above. And so we're also able to ingest different 3D models of actual structures and combine them so that you have a very realistic environment. Why does it matter? Because you've heard the expression, we want to train like we fight. We want to create the most realistic infrastructure so that other companies can unleash their creativity and develop the most realistic systems that can benefit the warfighter. Case in point, we recently had the opportunity to work with another partner, Battle Road, and Microsoft, and they have built an environment. This is a strategic and operational level simulation environment for the Navy. This was a demonstration only, but in this demonstration, they leveraged our geospatial capabilities to model the South China Sea, more specifically the Spratly Islands, and generate a scenario of wargaming where a commanding officer is in charge of a set of blue forces and can direct the next move of any specific element of that blue force. And then there are red forces, you can guess who they are, and they will react. And depending on their reaction, then there is a game that is played to test this commanding officer's grasp of strategy and planning and model possible scenarios and outcomes. Now, well, you may say, this is classic simulation. What does this have to do with the metaverse? Well, one thing, we are applying a geospatial foundation, and then somebody else is coming in and building a physics-based model of how things move in the world, and then applying some gaming logic of, if you take this action, then something else happens. And the main point is, several different companies came together to build this based on the fact that there are standards, that there are platforms and capabilities. So the number one thing I'd like to leave you with when we talk about metaverse is that there is no single metaverse, there is no single company building the metaverse. It is a collection of systems that rely on standards and interoperability and pervasive capability all around. And so in this scenario, a single commanding officer is playing the game and moving blue forces around, and some other algorithm is moving the red team. But imagine, let's take a break for a second here from what this is, and let's think about what this can become in the coming years, right? You are familiar, if you're here, you're very likely closely related to some sort of modeling and simulation system. And these systems have traditionally been built and integrated, sort of vertically focused on a single weapon system or a single subsystem. And now imagine a scenario in which a set of commanding officers can look at the strategic theater and operations here, and each one of these players is actually another simulator in of itself. And for example, on one of those ships, subsystems within the ship could be also different simulators. So you're actually giving people that have responsibility, let's say for radar operator or weapon system operators, to rehearse what maneuvers they would take and how those ripple effects get combined and aggregated at massive scale, so you're running a very large theater and operation. So I wanted to tee up this today to tell you that, A, we believe strongly that building a platform on which other people can unleash their creativity is our focus. This obviously is an application towards defense. We have folks that we're working with on other applications like logistics, supply chain modeling, energy. If you think about the situation that a power company goes through in trying to run their entire grid and monitor the status and the health of every element in the grid, that's very similar to the situation of a military commander looking at a battlefield situation and monitoring and maintaining the status of all the troops on the ground or in the air. So we are excited to partner with companies across the spectrum, and you will hear from my fellow panelists on more details about other aspects inside the metaverse of technologies that are coming or are already here and that will play a role there. And with that, I think that's my segment. Denny, thank you.
Great. Thank you, Gastel. Thank you very much. Great job. Thank you very much, Gastel. Great insights and great examples of building foundational technology that again, can be leveraged across other organizations. So shifting gears from the software ecosystem that's enabling a lot that's going on in the metaverse, we're going to focus with our next speaker on the hardware side of things. And what do we need? What kinds of technologies, what kinds of new form factors are coming to bear that again are going to be the platforms, no longer cell phones, no longer laptops, but the various AR, VR devices that we'll all probably be carrying around like we do cell phones now. So next up, we have Brian Vogelsang from Qualcomm. Please join me in welcoming him to the stage. Thanks, Brian. Yeah.
right, hi everybody. My name is Brian Vogelsang, and I work at Qualcomm. Qualcomm's multinational technology company. We build digital wireless technologies, processing technologies. So if you have a mobile phone today, there's a high likelihood chance that that has Qualcomm processing or wireless communications technology in it. And so I work within a team at Qualcomm focused on XR, and XR is augmented, virtual, and mixed reality. And these are head-worn devices, so AR glasses, VR headsets. And so what I'm going to talk with you a little bit about today is the kind of state of that market in consumer and how that market is evolving to impact commercial use in industrial, in military use cases, and really accelerating the pace of innovation that I think is going to help you all in your future simulation, training that you'll want to do with the kinds of use cases you just saw presented from Black Shark. How can we take that technology and bring it into the real world where you can consume it in 3D, not through a 2D screen, but in the real world itself? And so real briefly, when I talk about the metaverse itself and Qualcomm's sort of definition on it when it relates to XR. So the metaverse obviously is a big topic, and the question is really about how are you going to consume and interact with it? Is it going to be through a 2D screen on your laptops or on your PC? Certainly through a browser, through a mobile application, yes. But increasingly, you're going to want to consume the metaverse in more immersive ways, and XR technologies are the things that are going to help you do that, whether it's a virtual reality headset, an augmented reality device. So when we think about the metaverse at Qualcomm, we're thinking about it both from how do we enable it through mobile computing, but also how do we enable it through these more immersive technologies. And that's what I'm going to talk with you a little bit about today. So if we think about how we compute and how we've computed over the last, let's say, 40 years, it's all through in 2D. So we work through a rectilinear screen, through a keyboard, through a mouse, through touching the screen, the input itself. And we're transitioning to a new form of computing. We call it spatial computing. So this is where the screens disappear, where really the world becomes the home screen, the desktop. And so this is a major transition that we're moving through today. It's not going to happen instantly. It's something that is it's going to take many years to come to full fruition. But we really think that this is the future. And 10, 15 years from now, I think the idea of pulling out a smartphone and interacting with content through a 2D rectilinear screen is probably not the ideal way we think about consuming this kind of information, whether it's simulation or training. Now, Qualcomm's been in the market working on XR for about 15 years. We started on smartphones, then we early on moved to augmented reality and said, could we build augmented reality glasses? This is around 2012, 2013. We found that the technology just really wasn't there. We were taking mobile tech and trying to bring that to glasses, and so we shifted focus to virtual reality and helped make that market happen. So if you think about devices today like the Meta Quest or devices from HTC or others, the kinds of standalone virtual reality headsets that we all work with today, if we think about consumer, that's something that Qualcomm helped enable. So we built the fundamental technology that enables those devices to be commercialized at larger scale, and we've seen that happen. So you now have 10 plus million people who now have consumer virtual reality headsets, devices like the Quest 2, devices from Lenovo and from others that are now coming into the enterprise. And so we think that this technology on the consumer side is really helping accelerate commercial use and applications. So we see more and more enterprises adopting virtual reality for, training is a huge one, where it's if you can immerse someone in an experience, if you can teach them in a way that simulates reality, that people learn much more like they're learning with in the physical real world, and so they retain the information better, they can understand it better, it's more enjoyable for them to use the devices, those kinds of things. When we think about the market, we kind of divide it into 4 segments: enterprise augmented virtual reality, and consumer augmented and virtual reality. And of course, today the market is primarily virtual reality for consumer. So although enterprise is picking up, we've seen over the last 2 years, extremely accelerated pace of adoption, in part due to the fact that virtual reality headsets on the consumer side have now opened up accessibility to more and more enterprises. The other thing that was a key unlock for it was we took away the cable and the need for a PC. So now you can have a virtual reality headset that is standalone, that doesn't need that PC, or we can wirelessly connect it to the PC or to the cloud. And so what we're seeing is that the key technologies like the displays and the optics and the sensors and other things that are happening in consumer virtual reality are now helping us accelerate the move into commercial and into enterprise. And so I think this is important here because now you all will benefit from that. You'll see a faster innovation happening in augmented and virtual reality for the kinds of use cases you want to put them to work on. Okay, so augmented reality, I think you all understand the concept of this. This is where we introduce virtual content into the real world. So that simulation of, let's say, New Orleans, instead of looking at it on a 2D screen, what if we could put it in the real world here, and then we could shrink it down to a small size. We could scale it up, let's say to 10 or 15 feet. We could walk around it, we could manipulate it, or we could scale it up to life size and teleport to a specific portion of that city. That's the kind of thing that we can do with augmented reality. And there are a lot of challenges in delivering augmented reality technology today at scale. We think about devices like early devices in this market, HoloLens 2, Magic Leap. These devices are rather large, 500 plus grams. How do we get these devices more to the form factors that we wear in our eyewear today, which is 30, 40 grams? Well, that's an order of magnitude change. It's a complex problem because if you think about all the technology that goes into these devices, the sensors, the displays, the optics, the processing, the connectivity, all of that needs to be kind of shrunk down into a form factor that is very difficult from a physics and engineering perspective to still achieve high levels of display and fidelity. You want to be able to render the city in high resolution. You want it to look as good as it looks on a computer screen, but you want it in the real world. That's a difficult challenge to do if you get down to like 100 grams, let's say, glasses, so maybe 3 or 4 times the weight of what you have today in a typical glass. So, but it's not just about the processing technologies, it's also about the connectivity technologies, the sensing technologies. These are all evolving really rapidly through, again, through the supply chains on the virtual reality side, making these technologies more accessible, and the volumes that are happening on let's say the consumer virtual reality side for sensors and cameras and those kinds of components that will be miniaturized and will be brought into consumer augmented reality will then impact you all in augmented reality for enterprise or for commercial use case. Now, one of the problems that we think that needs to get unlocked to really make all this happen is changing the way that things get processed. So if you think about today, we have AR glasses that use a USB cable to tether to our smartphone. We're now cutting the cable and making that wireless. We think that this distributed processing of having the smartphone play a role and having the glasses play a role and have them work in tandem to enable the augmented reality experience wirelessly is the way that we're going to unlock the consumer ecosystem to move forward. And the same use cases that we enable there around training and simulation in, let's say, in the Fortune 500 could then be applied to military, to other commercial use cases for you all. And so ultimately, we think that this needs to get to, we need to get to these lightweight wearable glasses that we can have on ourselves all day, and we can really replace our computing devices like our smartphone and our PCs, but that's going to take some time. I think we're looking at 10, 15 years before we get there. But what we believe is going to happen is we're going to start introducing this technology a little bit at a time, where the smartphone is involved in doing the processing, the glasses are involved in doing the rendering and display and interactions, and then we'll see little by little, we'll see this technology adopted in consumer, and then it'll be available more to you all in enterprise-focused use cases. So I want to talk, double click into a little bit more of how that works. So the AR glasses themselves are wireless, working with a smartphone, and we take the cameras and the information that's sensing the real world, and we transmit that wirelessly to the smartphone. The smartphone then does the processing and the graphics rendering. So the actual GPU rendering that city, let's say, is happening on the smartphone. And then we take that information and stream it to the glasses and display it. But you may want to manipulate it with your hands, or you may want to manipulate it using your hands and your eyes. So now we need to take the eye tracking information, the hand tracking information that the glasses are collecting. We need to send that to the phone and have that phone be able to re-render the scene, kind of using that information as an input. And so we do this through a combination of an augmented reality processor in the glasses, as well as a smartphone processor. Now, the augmented reality processor in the glasses, we believe, needs to be made up of multiple components so that we can get to these smaller form factors. One is the processor that is taking the sensor input, like the camera information, and collecting that information about your hands, where are your hands positioned, turning that into a pose that can be then brought up to an engine like Unreal Engine, where an application can manipulate it. There's cameras that are used for things like eye tracking, and in order to solve this problem, we need to be able to it's very complicated to run lots of wires over from cameras that are in the glasses over to the processors that are in the glasses themselves. So we're doing some things to evolve the architecture of the glasses where we can minimize the need for that many wires to run. You can imagine bending the glasses. You want to be able to keep that as lightweight as possible. You want to be able to keep the shape and the form of the glasses as small as possible. So we're doing many things to be able to enhance this, and this includes a distributed architecture of processing in the glasses itself. Now, what does this look like in terms of size? I mean, this is a typical glass. If you think about, like, Lenovo has a glass called the A3. There's previous glasses from ODG, or even larger glasses or headsets that we see out there today in the market. They typically have one big processor on one side, and we have to run all these wires kind of across the glass, and that ends up creating more size. It creates more thermal, and ultimately a heavier glass. And so what we're doing is we're reducing the size of the chipset by doing this distributed architecture in the glasses, and now we can make a much smaller PCB, a much smaller footprint, and ultimately we can reduce the weight of those glasses, we can reduce the size, we can reduce the power consumption. Power is a huge thing. You think about these glasses that we have today, virtual reality headsets, they're about 5 watts. Between 5 and 10 watts. These glasses need to be less than a watt, ultimately, if we want to get to 30 grams. So you think about, how do we enable all this technology to come together in that kind of form factor? It's going to require a whole lot of innovation. So briefly, to close, one of the things that we see that's a big challenge is the software and the technologies that allow those spatial computers to sense the real world. So how do they understand the geometry of the world? If I want to place the 3D model of, let's say, New Orleans here, I don't want it to be 10 feet below the floor. I want it to know where the floor is. I want to be able to place it maybe at waist level. And so at Qualcomm, we're building a lot of the sensing technologies and the algorithms, computer vision, machine learning techniques that allow us to track where is your location in the environment, where is the augmented or virtual reality rendered content relative to you, where are your hands, what are the poses of your eyes, these kinds of things. So we're building the software technologies that help make this kind of thing possible. We're doing it through open standards. So we really believe that in order to unlock both the consumer and ultimately the enterprise metaverse, it needs to be using open tech. We're involved in an organization called Chronos and a standard called OpenXR. And so everything we're building on the software side is using open technology. And we're working together with folks like Epic. On the 3D engine side, we build SDKs that allow developers to be able to build applications and content. Like Blackshark, they wanted to build their application for augmented reality. They could use our tech stack using Unreal Engine to be able to do that in AR glasses today. And so I wanted just to highlight a couple of use cases just to give you a sense of how people are using this technology today. So this is a company called Arvisio. They're doing object recognition and guided work instruction for training. So you imagine coming in and you want to repair a piece of equipment. You need to be able to detect that piece of equipment and be able to lock onto that and then overlay information. Let's say it's guided work instruction about how to step by step, repair that piece of machinery. And so it's companies like these that like Arvisio that are providing the tech stack using AR glasses, from Qualcomm, and software like I previously showed Snapdragon Spaces as our product that enables that to happen. And so this is the kind of tech that's available today on devices like HoloLens, and we're bringing that to a new form factor, more of the lighter weight like I shared. Another one is a company called HoloLight. Now, I talked about being able to distribute the rendering between the smartphone and the glasses. We also think the cloud will play an important role in here. How does the cloud potentially do some of the rendering? If that city in New Orleans needs to be rendered at using a 300-watt GPU, we can't do that on the smartphone. So we need to be able to offload that to the cloud. And so there's a lot of work happening to enable the rendering to be done remotely in a low latency, extremely low latency way, where we can do some of the same things we're doing between the glasses and the phone to the glasses and the cloud. And this company HoloLight is exploring the frontier of this. You can also do it between the device and the PC. So if you have a PC nearby, you can use the wireless network to enable it. And the last company I'll highlight is another company called HoloOne. They're doing mixed reality collaboration. So a lot of augmented reality needs to be co-located and shared. So if you're doing a simulation like was showed earlier with the like naval warfare, you want to be able to have 5 or 10 people perhaps looking at that simulation in 3D in real time. So how do you enable that co-located shared experience where everyone in that simulation can see the same thing at the same time, no matter where it's rendered properly from the perspective that they're in? So this company allows you to take digital twins and be able to render those work in a collaborative type way, but whether the person's remote or whether the person's local, and they're also involved in remote mentor type use cases where you have, let's say, someone who's working on a problem, but they need help and they need someone remote to be able to see what they see and be able to kind of be the remote hands that can tell them this is what you need to do to solve your problem. So I think that there's just some exciting use cases we're seeing that are helping shape the enterprise metaverse. So thank you all. Appreciate it.
Thank you very much, Brian. Thank you, Brian. Again, great insights on some of the foundational hardware technology being developed right now. That again, I think we're all seeing definitely going to be making a significant impact on all the work we're doing in our own industries. As for our last speaker, again, shifting gears a little bit more to a very interesting individual who has a background working at Pixar, developing technology for Pixar movies, and how he's taken that work and evolved it into the robotics company that he's founded and started. Some great insights and stories to share with us here. Please join me in welcoming Apurva Shah from Duality Robots to the stage.
Thank you.
Hey. You're not stepping away.
All right.
There you go.
Thanks. Good morning. Thank you so much for coming out for this session. My name is Apurva, and I'm a self-confessed Metaverse practitioner. So, Gustav talked a lot, about how, you can use digital twins, GIS data to build large contexts. Brian talked about accessing the metaverse. I'll focus a little bit more on what are some of the things that you might want to do in the metaverse and sort of why it matters. So let's see if this will advance. Oh, it is advancing. Okay, perfect. Our focus is on using the metaverse to solve real-world problems, and that's really what what we're after. So a little bit about the company and my co-founder and me. So Mike comes actually from a very different background than me, my co-founder. He actually worked at Caterpillar for a long time, participated in the DARPA Grand Challenge, which really kicked off self-driving cars. So what I say is that he's fully rooted in the physical world. My own background is actually exactly the opposite. I'm very much on the virtual side, worked at Pixar for most of my career. And that's why I say I'm a metaverse practitioner. I just didn't know it then, right? Like we focused on creating these worlds that were fairly complex. Like here, you see the world from Ratatouille, which is a Paris from Ratatouille. And these worlds are very dynamic. They're very scalable. Look at any Pixar world. You look at a Star Wars film. You look at pretty much the world of Matrix, the movie. I mean, these are complex worlds, and they're very dynamic. They're highly simulated worlds, but they're just done for storytelling. So now the question is, can you take some of those ideas and apply them more in an enterprise context, more in a defense context? And that's how we started the company back in the fall of 2018, is just to singularly focus on this question. Like, can you take the tools, techniques, the pipelines? We saw how Black Shark also was originally rooted in the gaming side. We wanted to see if we could take these techniques and essentially loft them into solving these real world problems. So a couple of level setting things first. So, Danny mentioned defining the metaverse. So I'll take a crack at how we view it. And by no means, he's absolutely right. We're at a very foundational stage still. So, this thing is totally evolving. But the way we think about the metaverse is from a digital transformation lens. So we think about the metaverse as a virtualization of space, a physical space, along with all of the assets and interactions within it. Now, when you look at it from that lens, it suddenly starts to make a lot of sense. Like at the end of the day, what does technology enable, right? It enables us to be more efficient, more cost-effective, go after problems that are larger than we could otherwise, right? And by virtualizing space, there are many kinds of problems that actually become tractable that were not before. One of the primary ones is data collection. Data collection in the physical world is actually quite expensive. Right? But if you can virtualize that, it becomes very efficient. Similarly, if you are trying to design and develop robotic systems, autonomous systems, self-driving cars, self-driving robots, we work with DARPA on essentially off-road autonomy. Validating these systems, designing these systems in the physical world is very time-consuming, very slow, and it's not very efficient. But if you can move that problem, if you can transform that problem, you can virtualize that space and that problem, it becomes actually very efficient. Another level setting thing is on digital twins. Fundamentally, when you talk about a metaverse for enterprise, it is really rooted in making sure that the data that metaverse produces is predictive. And in order for that data to be predictive, it has to be grounded in these digital twins, right? So because because this phrase digital twins has, it's been used in many different contexts, so just from a level setting perspective, our focus is very much on predictive twins, right? So there are digital twins that are focused more on data collection on the IoT side. And I would argue that actually it's a continuum. That side of digital twins allows you to model twins accurately. So if you're going to say like, hey, I'm going to predict this twin forward, right? Then basically, you get this ability to model it on real-world data. Therefore, when you simulate it, it actually produces data that is predictive of the real world. So it's actually, it's a continuous loop, really. So with that in mind, right? So you look at the consumer metaverse on the one side and the enterprise metaverse on the other side. I mean, there are obviously things that are really great about the consumer metaverse. It's highly scalable, right? Like you can have massive worlds. Fortnite has had 26 million people in their last concert, and so it's got a lot of scale, right, to it. It's also it's very performant, right? So basically, you have some really the rendering quality, we talked about the rendering quality. We talked about the speed at which things can run in real time. I mean, those are the things you want. But then what's missing? Well, what's missing is that it's not accurate, right? It's not necessarily predictive of what will happen in the real world. And if that metaverse data is going to be of any use to anybody, right? If you're going to try to solve real world problems, then it's got to be predictive. Otherwise, that data has no meaning. It has no value. You can say, oh, I made this data very efficiently. But if that data doesn't actually have any predictive value in the real world, then it's useless data, right? So those are the problems that need to be closed in order for that consumer. So it's the classic sort of dual-use gap, dual-use technology gap that you have, right? You need to close that gap, and that's really what we're trying to do. So I would say that here are some of the founding concepts for us in terms of when we talk about the enterprise metaverse or the metaverse to solve real problems. The first is that it is not a metaverse of avatars; it's a metaverse of digital twins. Remember that's why I introduced that as a sort of level-setting concept, right? Like if you start with the digital twins that are predictive and accurate, the data they produce when you bring them together within these metaverse scenarios will also be accurate. So it kind of goes back to that founding principle there. The second is, of course, that you want the data. So at the end of the day, when you play a game in Fortnite or something, right, or you build something in Minecraft, right, these other metaverses that exist on the consumer side, you're just doing it for the entertainment value of it, right? It's an engagement, right? But the enterprise metaverse, this metaverse to solve real-world problems, you're running it essentially to generate data. The data is the valuable part of what comes out of this metaverse, right? And so these are just some of the sort of founding concepts that, and by the way, these are very hard-won lessons, right? Like a lot of it sounds sort of obvious, but in the last 4 years, we've been working very closely with partners, with our customers. And so my hope is that some of this will at least help you in your own metaverse journey as you go forward, right? So let's assume that this metaverse exists, right? So let's assume that you actually do have a predictive and accurate metaverse. What might you do with it, right? So the first thing is that data. We talked about like, hey, collecting data in the physical world, instrumenting the physical world for data collection is actually hard and expensive. And even then, the data is often incomplete. The data is not annotated. That data it's not structured data. It doesn't make sense. You have to then go through a bunch of trouble. A lot of it is manual, right? So one of the things that you can do from this virtual world that you have, right, is you can collect data very, very efficiently, right? So that's one problem. And these are the low-hanging fruits, right? So whenever you have new technology, right, the first thing you want to go after are problems that are particularly suited for that technology. So data collection is certainly one. And guess who needs a lot of data? Machine learning. Machine learning models just absolutely crave data. So the fact that you can collect data efficiently, and data that's actually structured and annotated, is really, really useful. And so half our customers actually come from this side of the world. They're basically building AI models for everything from, let's say, self-checkout at a retail space to doing manufacturing inspection, right, or QA manufacturing inspection. The second set of problems is really in the robotics side, and this is really close to my co-founder's heart, is around robotics, right? So we are increasingly seeing these intelligent systems making their way in everything, from security to basically, warehouse operations. And what actually makes these systems intelligent is knowing how to deal dynamically. The world is a chaotic place, right? I think in defense, you talk about the fog of war, basically, right? And inherently, if you want an intelligent system, we are assuming that system knows how to operate in a meaningful way within this dynamic, chaotic world that we all live in. We just do it very casually and don't even think about it, right? But a machine has to learn how to do it. And if you can, you can teach the machine how to do it in the physical world. Self-driving cars actually tried to do that. So the original DARPA challenge only had hardware teams that knew how to build physical cars, right? And then for the last 10 plus years, they've been trying to, everyone from Tesla, to Waymo, et cetera, they've been trying to train these cars to become autonomous in our physical world. and still falling short, right? Because turns out our world is incredibly complicated, right? And so this time when DARPA has a challenge now that we are participating in, called RACER, which is for off-road autonomy, right? So this is to actually, especially logistically, to support forward bases and things of that nature. And they were smart enough to this time include simulation. There are 2 simulation companies, one of us, being Duality. They included us in RACER, and we partner with the hardware teams exactly for this reason, right? It's much more efficient to iterate and build these systems, in the metaverse. And then finally, we talked about training, right? How do you make sure, so if you have these incredibly complicated systems and system of systems, right? How do you train people? Ultimately, the human is going to be in the loop and is going to be responsible. And how do you get these humans then to actually know how to deal with these complex systems, right? So these are some of the ways that we believe the enterprise metaverse is meaningful. It's meaningful in lots of different ways. So I'm going to switch gears a little bit and talk about how we are trying to solve this problem, right? So I think some of my other speakers have already mentioned that this is too large of a problem for any one company or any one entity to try to solve. And I would argue in the same way, it's great to see that collaboration between the entertainment side, the enterprise side, the defense side, because it's going to take everybody. And let's be honest, a lot of people who talk about the metaverse talk about it as the next generation of the internet. Well, guess who started the internet, right? It's really defense. There was enough capability there to do that. So I think it's really important to have that, not a 5-year, 8-year horizon that a commercial company might have, but have a 10-year, 20, 30-year horizon, which really requires support from government, from defense, right? So our goal is to build like an end-to-end solution for this, right? So we want to build a digital twin integration platform. And I'm going to argue that to solve these complex enterprise metaverse problems, you really need to have all of these pieces in place. And that's what we've seen in our work with customers. So what we are trying to do really is take what we've learned from the internet and sort of apply that to the idea of building the enterprise metaverse, right? So using patterns, certainly open source, open standards, open source patterns, but also really thinking about as a developer, like who's going to build this? Well, it's going to be developers, right? So what patterns are they used to? And so one of them is around breaking up, right? So on the data side or the data modeling side, we are advocating for a standard based on something called universal scene description, which actually comes out of Pixar. Snapdragon supports it too. Brian and I were talking about it before. And the idea is really to encapsulate. Digital twins are there's too many types of digital twins, too many domains in which they're applying, we would apply them. So really thinking instead about an encapsulation standard for digital twins, right? That every digital twin at least is dressed within the same sort of standard. And then similarly on the programming side, how do you control behavior? So using Python, which is already a well-established engineering standard, and sort of using that. So I'm going to walk you, finally, just to close out, I'm going to walk you through a case study that, from a project we recently did in partnership with Amazon AWS, where we're trying to run this massive simulation in the cloud, essentially, using a new service that they just launched yesterday called SimSpace Weaver. And we're also leveraging, Epic is a partner, we're also leveraging their Unreal 5 city environment, city sample project, and putting those pieces together, basically to show a city that's roughly like New York, right, about 20 square kilometers, running in real time with over 1 million entities, right? So I'm going to walk you through all of these steps and again make that argument for why all of these are important. So first is you have to acquire digital twins in some way. And here, again, GIS partners like Black Shark, Maxar, that really comes into focus. Cesium, there are several other ways. In our case, we used actually the city sample project that comes with Unreal 5. So this is a procedurally generated environment. The second step, and this one, I don't think there's been enough focus about this here, is how do you manage, right? So if you're talking about these massive enterprise metaverses, right, they're made up of thousands of digital twins. And digital twins, some of them are system of systems digital twins. So it's like, how do you manage this entire digital twin library, right? So that's one of the other pieces that we've been working on is actually helping you. And we figured this out on the entertainment side a while back, that you need to have a very strong asset management system. But in the case of the enterprise metaverse, the real promise is being able to share, right? So if I'm a private company working, let's say, with the Army or the Air Force, and then there are other contractors, maybe Lockheed is involved, Raytheon, how do all of these partners, when they're working on a project, share digital twins with each other securely, right? And then be able to assemble them into scenarios that are going to generate the data I care about, right? So this is a lot of the plumbing that doesn't exist today and needs to exist before the metaverse will really become practical and valuable for people. Otherwise, right now, every time you want to do something with the metaverse, you're talking about a 3-4 year project, right? And that's obviously not practical. And then finally, the simulation piece. I won't go into the technical details very much. There's a blog on our site, and you can check it out. But very roughly speaking, the way we run the simulation, we take this 20 square kilometer area, and we break it up into partitions, into spatial partitions. And each partition is responsible for its compute complexity, or basically managing the entities within that partition. So we have about, I think, 160 partitions that run over 16 cloud servers or 160 virtual machines, basically, right? So it's a very massive scale. And that work comes from the AWS team, right? So they are basically, we're a launch partner to this thing. I do want to call out the digital twins as well. So remember, I mentioned that for us, we really think about the enterprise metaverse as a metaverse of digital twins. So you'll see there's a digital twin here for, who's the person calling. So this is an emergency response scenario. So New York, imagine rush hour, gridlock. If you want to try to get an ambulance to someone in distress, how can you think about that, right? And how do you plan for that? What are strategies you could apply for that? Now, one of the really interesting things is that up until now, right, and as I said, I've been a metaverse practitioner for over 20 years, right? Like, I've done simulation on the entertainment side for a very long time. There's inherently a trade-off up until now between the size of the simulation you can run and essentially, whether it's real time or not, right? So if I want to run a real-time simulation at this scale, 20 square kilometers, over 1 million entities, right? I'm trading off fidelity at some level, right? My fidelity has to come down. So if I have a discrete event simulation, right, that it's a more top-down approach of how I'm going to do routing. I'm going to do some A-star routing. I'm going to get my ambulance there. What am I missing in this? Again, what I'm missing is the chaos of the real world, right? I'm missing that aspect of it. And also increasingly, and this is very relevant to defense, right? Like, you think about edge intelligence, right? We talk about edge intelligence. Nobody wants that command and control. We know that doesn't work by itself. What you really need to do is bottom-up intelligence combined with top-down planning and strategy. How can you combine both those things? So what a simulation at this scale allows you to do is really to have that clear top-down strategy, but combine it with that chaos that might be happening on the ground, or the edge intelligence that needs to come into play, and then have that data actually travel back up, right? And I'll show you some example of that as we play the simulation here. So what you'll see here is just, in the beginning, is just to show you the scale of the world a little bit. And this is all running in real time, by the way, from the cloud, right? So I just want to point that out again. And this is very fresh. This was literally launched yesterday. It was announced by AWS yesterday. So this is very new stuff. And what you're seeing is actually entities that are simulating. They're all, intelligent entities. They have collision avoidance with each other. They're moving, like I said, over 1 million entities. Now you can see the ambulance. This is the dispatch view. The ambulance has picked a route. And what I want to show you here is that actually you can have an officer, a traffic officer, can get to an intersection and clear it, right? So when you're looking at routing, if there is a blockage somewhere, it's possible for someone on the edge to be able to clear that blockage, right? How do you incorporate that into a simulation of this scale, right? And then actually you can see that the ambulance is a fully autonomous agent, actually, right? It's got full set of virtual sensors on it. It's got a LiDAR, it's got a radar. So it's actually, and it's able to avoid the other vehicles. So all of this is done essentially, again, in real time. So these agents, right? So whether it's that ambulance that's routing itself, it's an autonomous agent, or the dispatch controller can essentially route and send traffic officers to intersections to help clear them out. And that's the difference, right? If I'm doing a full top-down simulation and strategy, I might be like, oh, there's a blockage there. Oh, too bad, right? That's going to be too much of a time expense, so I'll go this other way. But what if you could actually clear that blockage? And then the question is, if you send an agent out to do that, were they successful in doing that, right? So this is really the advantage, because it's one thing to say, oh, I can do 1 million entities and I can have actual agents that contribute back. The question is why? Why is that useful? Why is that important? Well, because when you have that closed feedback loop, I mean, think about what you mean by fog of war. That's exactly what you mean, right? You have a strategy, but what's happening on the ground? And how is that contributing back to what you do? I think that might be one more slide. So this is just my last slide. So again, going back to that idea of like, why are you running this enterprise metaverse? You're running it to generate data at the end of the day, right? So the question is, how do you know whether the data you're generating is junk or not, right? You can easily binge, just like we can binge on bad food, you can binge on bad data, right? So we've tried to come up with some ideas around what makes data useful. So we call it a 3I framework. You can actually score data, to see how relevant it is. Is synthetic data actually indistinguishable from real world? Because if it's not, that means it's not really accurate, right? So that's not particularly useful. But then having data that only matches the real world data is also not great. You actually want it to be information rich. It should bring some new information, right? Otherwise, your machine learning model is not going to learn anything new. And so we've kind of put this framework together to help both us and our customers understand the value of synthetic data. I think that the promise of this is really immense. But I think that one of the things that any new technology faces is a sort of hype cycle, right? And we are very much in peak hype cycle right now for the metaverse. Like I said, I'm a metaverse practitioner for over 20 years, and I'll keep doing it for the rest of my career. And so I think the important thing is for people solving real problems, is being able to roll up your sleeves and so just really digging in, right? So I know this is the next big thing panel, but I mean, a lot of the problems we're solving are not new, right? And in fact, a lot of the techniques we are using to solve these problems are not new. It's a question of the framing of how we bring all of these pieces together. And I think that there's a real potential here to change how we think about some of these data problems using the metaverse. So thank you so much.
Thank you, sir. Great job. Great job. Thank you very much, Apurva. That was a great final talk here on this topic. Please join me in thanking all of our panelists. Some great insights. Great to get the perspective from a number of different corners of the metaverse, of what we're trying to solve here. It's not, I love the points being made about not being solved by any one company, any one industry, and clearly there's a lot of different aspects of technology that need to be addressed if we're going to grow an environment like this. So we are done with the presentations. I'm going to ask my speakers to come back up on stage. And we're going to do a little bit of Q&A. I promise not to make them stand up here. We don't have chairs, unfortunately. But please, if you've got questions, we've got a few folks walking around with microphones. I'm going to kick it off. I've got just a couple of questions that have come up as we've talked. I would like to know, each of you've talked a little bit about where technology is going, where your respective technologies are going, and how that's going to affect the metaverse. I'm curious what you think the biggest challenge is. What, either with your own technologies or with the industry, what do you think the biggest challenge is we're facing to really envision an enterprise or defense metaverse? What do you think we need to solve? Brian, you want to start?
Yeah, so when it comes to hardware, it's really display and optics in the hardware. That's the most challenging component. It's how do you miniaturize it, but also how do you, if you want to augment the real world, how do you augment as much of it as possible? And that is a really difficult and challenging problem to technically engineer. And there's physics problems and other material science issues that need to get resolved to make that happen. So I think that the rest of the technology is moving really quickly. We want to accelerate the pace of innovation for display and optics.
Got it. Great. Yeah, great insight. Gustavo?
Yeah, I think we talked about no single company doing it by itself, and in order for that to really occur, we need standards that people adopt, and we need mechanisms that multiple companies can trust. I think we're in the infancy of some of these larger standards. A lot of standards already exist. So the other point about Metaverse is that it will be a set of many standards coalescing, not a single one. We think about it from a perspective of, especially from our specific corner of the Metaverse, which is the geospatial angle. When you look at some solutions based on photogrammetry, well, those are pixels. But pixels have visual meaning for humans. How do you bring that meaning to machines? We apply semantical interpretation of that through our machine learning, so we can tell you something, if a pixel belongs to a house, to a tree, to a water, but how to create that in a way that everybody speaks the same language and say, oh yes, we all understand what this pixel means, whether you're implementing a simulation system or a visualization system or a multiplayer scenario like Apurva described.
Yeah, excellent point.
From my perspective, I think investment in this space needs to get more structured. I think right now there's a lot of different experiments people are running just to figure out, but I think we should realize, I know there's, like, for example, we talk about the race to space and things like that. This infrastructure is just as vital. Building an effective metaverse is vital for our national economy. And I think really thinking about investment in a more holistic way than we have been up until now, I think is really important.
Excellent point. Great segue to my next question, and then we'll open it up to the group. We've got a lot of people from the defense industry. We've got a lot of people from defense itself, from the government itself. If you had an ask of those people, of people in government, of people in defense, that something that they could do or something they could take back to their leadership to help this along the way, what would it be? Apurva, I'll start with you. You might give the same answer, but
No. I mean, again, I think that there are problems that we've considered, and it's kind of given is almost a given that these are intractable problems, right? Like there's no way to get meaningful or deterministic answers to certain difficult problems around strategy. But I really think that it is possible to find those answers, right? And again, by that virtualization, as we were talking about it, from virtualization of space, it's possible to do that. It's a much more efficient way to make meaningful, grounded decisions, right? And so I think that's, again, I would go back to, I think thinking about this not in a piecemeal way, but really thinking about what would it mean, right? Just fast forward, right? Fast forward to a state where, let's say that this kind of a metaverse does exist. What are the kind of questions you would ask, and what are the kind of problems you would try to solve, right?
Great, thank you. Gustavo?
I would say, let's rethink the way the branches of service and industry engage. We recently had the opportunity to work with a branch of the Israeli Defense Forces in what we call a hackathon scenario. So we came together for 3 days, our engineers, technicians, engineers, and stakeholders from their side, concentrated effort, and in 3 days we were able to stand up an AI pipeline that processes petabytes of imagery and yields answers from sensor to decision that wouldn't have been possible otherwise, because we had the people that are going to use this information, the analysts. We had people that were building their systems and thinking about things like CI/CD and DevSecOps, And we have our team that was the subject matter expert of what our AI can do for this specific sensor, all collaborating intensely in an experimentation environment. The result of that is something that they used to take 8 weeks to process is now done in less than an hour. And that wouldn't have happened if we went through a traditional process of, hey, here's a set of requirements, now let's go back and forth on these requirements, now submit a first proof of concept, et cetera, et cetera. Right. So I think there's an opportunity for across industry and services to think about more of this agile and sort of hacking mentality to allow these new things to flourish in a safe space.
Yeah, excellent point. Excellent point. Right?
Yeah, I think I'd echo that. I think that the feedback loop around the unique and diverse use cases and the needs, the problems that you're trying to solve. If we look at technology companies that are building devices, or suppliers like Qualcomm who are enabling them with the technology, sometimes we're insulated from the real problems that you're trying to solve. And so I think the best way for us to get closer to that is to work with the people that are building the technology and the folks who are using the technology. So I think like being more engaged with the companies in the ecosystem that are building this tech and really helping impart the knowledge that you have, real world knowledge about the problems, so that we understand them, so that because we're building 3-5 years ahead, right. And so if we don't have those insights, we might miss the mark. So
yeah, excellent points. Excellent points. Thank you for that. We'll open it up to the audience. Are there questions for our panelists here? Okay.
So, I mean, we are going through FedRAMP certification right now. And as you said, it's a process, right? And we want to do it right, obviously. So it's not just about getting the certification, but making sure that we have all the right processes in place. I think I'll answer your question maybe a little bit more broadly, right? So there are obviously cloud service providers, all of them have government clouds. And effectively, what you're really looking for is a pixel streaming solution that you can run from a government-approved cloud, basically. I don't know if that answers your question or not, but yeah. So at the end of the day, the sort of pipes exist, but as you pointed out, there isn't I believe a solution, a pixel streaming solution that's FedRAMP approved. Right out of the box right now.
I do think this goes back to some of the comments about needing government to understand technology is great. Our ability as industry to demonstrate that technology is great. When it comes down to actually deploying it, in restricted environments, I'll say, not necessarily classified environments, but restricted environments. That's a big problem that I think as an industry we need to solve. I don't know that there's a good answer.
If you promise not to tell broadly, I'll let you in a little secret.
You're being recorded, just so we're clear.
Just kidding. So we've been working with Microsoft on a way to take our entire stack and move it over to secret and top secret cloud environments so that it can go all the way up to IL6. But these are foundational technologies. I think the scenario that you presented of a virtual classroom is a very specific one. Mm-hmm. I would say that the current state of affairs is you have secure cloud computing environments that you can leverage. We are going to have our geospatial capability available in these environments, but then there's another set of other capabilities that would need to be migrated into the right level of security.
And when it comes to virtual reality, so we've done a bunch of work more in K through 12 around virtual classroom. We worked with a company called Victory XR. They do a lot of innovative work in this space. We also did some higher ed work with them with Morehouse College around enabling some of the first virtual classroom metaverse experience. This was kind of in around 2020, so during the height of the pandemic, and that was adopted very nicely. And so, but again, that doesn't necessarily solve your problem around how to
maybe move in that way.
Yeah.
Thank you for the question. Another question? Go ahead.
Hey, thank you. First off, thanks everybody for great presentations. I work for the U.S. Army, so my question is going to be based around training. So I work with the Army Mad Scientist team. We sit at the headquarters for training and doctrine command. So I want to talk about modeling of urban environments. So Gustav, you said the military wants to train how they fight. And so if we're going to be fighting in an urban environment, we're not only going to need to know where the streets are and where the buildings are, but we're going to have to be able to train inside of those buildings. So I wanted to get your opinions on the next level of detail there, where if we have an urban operation we're training for in a virtual environment, can we clear 30, 40, 50, 60 floors of skyscrapers, rooms within them, people within them, and also the subterranean component of that, subways, infrastructure, basements, things like that. So I just want to get your opinion on that next level of detail. Thanks.
Yeah, this is a recurring topic of conversation I have with folks where I get asked like, hey, can you guys do the inside of the building? The short answer is not with a satellite. You need sensors that can go inside the building and capture that. So we have actually partner companies that have a capability to LiDAR scan the interior of a building and then geo-reference that, and then we can integrate it into the model. So once you have something that's, to Apurva's point, there's a data capture component, you clean up this data, you make sense out of it, and you integrate it into the model. So that's the problem. The issue is, how do you do this? It's easy to do this on a facility that you own and you have access and you have control of. How do you do this behind enemy lines? And so there are a couple of grand challenges out there. It's not something we actively participate in, but we have been invited to look at those challenges of how do you use AI ML to guess what the interior of a building looks like. So the good news is buildings are pretty, let's say, contained in how design goes. So there are rules of architecture and construction that people have to follow. And so there are ways that some folks are approaching this as how do you guess based on the location of where the door is, and there must be the next thing. If this is the garage, the kitchen must be here, therefore this door must lead into a living room or something like that. And then for high-rise buildings, there's certain ways to guess what the interior space looks like. But again, I love the 3I framework, right? So that there's information that is likely to represent the real world. And so in a training scenario, you could use this to say, here's how you go into rooms and do this type of event, but they're not going to be the actual, if you're training at a tactical level and saying this is the building that you're going to go into, we're still limited by the fact that you need the actual blueprints of the building to be able to do that.
Great goal.
Yeah, she's like,
Yeah, please.
Yeah, so
please.
actually, a quick question also is, whether you need it to be a specific environment or if it's more of a training environment. So with DARPA, for example, they wanted to create a proving ground for these vehicles that actually had all of the classic kinds of challenges that the vehicles would run into. So we in fact use a process similar to what we would use at Pixar, where we in fact hired a Pixar, on our team we have an art director who worked at Pixar before. And we sat down with different parts of the Army looking at, okay, which are the challenges you're interested in? And then we built this 80 square kilometer environment that has all of those elements in it. So that's another way you could approach it in the absence of data, is actually identify the sort of archetypal challenges that you're trying to look for and then build an environment with all of those elements.
Excellent call.
I just had a follow-up that I think maybe it's for another panel, but based on that, I've seen some research on the use of Wi-Fi, able to see into a number of buildings. I know there's some potential intelligence oversight concerns about something like that, privacy, everything else. And I know Amazon right now is using a number of smart devices hopping along people's Wi-Fis to let you know essentially what's happening all over the neighborhood. Is there potential in that area? And the reason I say I think you make a good point of for training, it's really what are you trying to achieve? What are you trying to simulate? What kind of environment do you need to be in? But in the case of modeling and simulation for this, if we're looking at more detailed mission planning for actual operations and precision, is that a possibility or anything you've seen?
Yeah. I haven't heard about, I heard about people looking into Wi-Fi. One of the things, if you have a Roomba vacuum in your home, guess what it's doing?
Yeah, great call.
Right? But these become, this gets into the realm of how do you gather that intelligence if you're dealing with an enemy / adversarial power. That's a bit beyond my knowledge of sources and methods for that stuff.
I think you just solved it. We just send everybody a
Roomba vac.
Roomba,
Here you
and
go.
then it's a gift, and then just collect all the data. Great. Thanks for the question. Any other questions? Someone over here?
Yes, sir. My name's Paul Grostad. I work with NATO's Warfare Development Command in Norfolk, Virginia. Certainly see a lot of great potential with the metaverse, but from a security perspective, I have some concerns of the threat potential in the metaverse, and might not be your area of expertise perhaps, but from each of your perspectives, what are the greatest potential threats and how can we mitigate them? From looking at a potential adversary or a malign actor, of course.
I'll start quickly. Just an interesting story. I was at another conference doing another panel about the metaverse, and I had not thought about that particular question, security in the metaverse. And there were a few other folks from government on the panel, and it turns out there are a lot of people thinking about it and thinking about how do you gather intelligence in the metaverse. And that as a concept freaked me out. But there are people that are, because if you think about the internet as a analog or a potential analog to the metaverse, there's all kinds of agencies that are going out and trying to find people that are doing nefarious things on the internet. Those same organizations, I think, are at least starting to think about it and starting to talk about it and trying to understand what kind of people do you need, what kind of technology do you need, what does it even mean to do that kind of intelligence gathering in the metaverse. But so just anecdotally, I know there are some agencies talking about it. I don't know that a lot of it's been solved, but they've got people thinking about it. Anybody else?
Look, our experience is that let's frame what you mean by the metaverse, because if you imagine, to Danny's point, hey, it's the next version of the internet, we know that anything connected to the internet is likely a target. It's likely hackable or maybe already been hacked. If you're thinking about high security value systems, the way we operate is we contain these into a separate environment. And so I think one of the biggest challenges we have, even in a air-gapped or contained environment, is the contamination of the data that's going in. How do you know that the data is going in? It has not been tampered with, right? So that's one of the things, especially in our case, we think about it from creating a trusted chain of we've processed this data, we know it's our data, we are going to host this data in a location that's been validated and signed off. Thus the comment I made about working with cloud providers to have that secure environment that's been blessed by governments in these applications.
Yeah,
Anybody
I mean, the metaverse. So again, it's like I think an internet analogy is very valid, right? Like there isn't a metaverse, or I mean, it's all one, but then it's also not one in that sense. Like so, you can absolutely operate a metaverse that can be highly controlled. In fact, we are building our platform ground up to be very secure. Even these digital twins, if you share them with other parties, that you will have complete control over that sharing. It'll be all encrypted, right? So I think you can operate very securely a metaverse. I think you ask maybe a broader question, which is that in the consumer metaverse, is there an opportunity for for espionage or data collection, right? And I would say absolutely, right? Absolutely. And I think definitely something to keep an eye on, you know.
I think if we fast forward to the next 5 to 10 years, where more people are wearing spatial computers, those are always capturing, right? They're always gathering information about the environment because they need to determine your position and they need to localize you relative to augmented content you're seeing or other things. So they're using computer vision to essentially generate like a point cloud of the environment in real time and then localize you. And then that information could be obviously stored in the cloud and could be accessible, you know, by bad actors. So, but they're also, these spatial computers will understand the exact location and orientation of your head, where you're looking at any given point in time. So they understand your eyes, maybe where you're looking. And so you think about the kinds of data and how do you both from a privacy perspective, but also from an espionage perspective, how would you protect that information so that, you know, you can't rewind time and look at, all right, this is, you know, exactly where someone was walking and looking and exactly, you know, throughout their day. Kind of like you can do this on Google today. If you use Google Maps, you can kind of go back and see, all right, what routes did I take, and Google will show you. But this is a whole nother level that we're talking about here.
Very interesting. Yeah, a lot of things to consider. We've got a few more minutes, maybe one or two last questions. Anybody? Right down here.
Yeah, the question is there a bigger concern about these kinds of technologies and privacy, and is that going to impede adoption? I think it's something that the industry needs to, it's one of the number one concerns that industry needs to be thinking about is how do you put the right sensors on the devices, and then how do you store the information in a way that is protecting the privacy of not just the user who's wearing them, but also the other people around them. Because if my spatial computer is hoovering up other information, there's going to be people who didn't opt into, sort of like you know, how we have the you know, the folks collecting information for self-driving cars and vehicles and other things out there. You know, you do blur faces and license plates and other things. So, so yeah, I think this could potentially be a challenge if not addressed and put at the top of the list of problems to solve. And I think there's a lot of work happening in this area right now, and you know, it definitely will. We definitely need to solve it in order to not impede adoption.
Great question. Any comments? Maybe one last question. Anyone? One last one over here.
Is there any advancements planned in the area of instructional design? For example, if you know we have educators who want to start creating objects to put inside the metaverse, do they need to be able to code in Unreal or in Unity, or would there be some kind of expectation that will be more of a simplified version of this, which your typical PowerPoint-based instructor can now move into the metaverse and start creating, you know, 3D artifacts there?
Yeah, it's an interesting one. So my crack at it is there are some fundamental things that are available right now. For example, Purva mentioned USD, Universal Scene Description, is one such standard. And there are many applications that can generate objects in that standard so that it can be consumed in different environments. We can consume it, we generate it, we look at it, we employ graphical artists that analyze what architecture looks like in different parts of the world, and they create our models and archetypes for structures. So you need sort of this blending of someone that has the technical talent to use this in descriptive languages like we do, our procedural grammar, but also have the artistic understanding of, hey, this is a neoclassical building. These are the features of a neoclassical building. This is a Mediterranean building. What are the features of that building, and so on. By the way, shameless plug, as of an hour ago, we announced publicly in partnership with Epic that our Unreal Engine plugin is freely available on the Epic Marketplace. So anyone that's interested in trying their hand out can actually download the plugin. It contains that scene in New Orleans that I showed you, and start building things on top of it, right? So Unreal is actually one great example of how to quickly get started in developing for that space, because it's got a lot of capability in there, and then through plugins you can augment and do that and start building models and simulation and adding objects to it and so on via those marketplaces.
And I'll just add one last point there, which is that working for a company like Epic, fundamental to our vision of what the metaverse might become and what it might look like is providing the ability for anyone to enter into a metaverse, whatever that happens to look like, and build whatever they want to do. And so that's true on the commercial side and on the entertainment side. It's also true on the military side. If we don't, it's not going to be a small group of people. When you think about the amount of content, the amount of immersive environments we want to build, it's not going to be small companies doing that. It needs to be, like with the internet, it needs to be anybody. Anybody right now can go out, create a website, and put content on it for whatever they want. Anybody can do that. My 7-year-old can do that. The metaverse needs to be the same way. So there's a lot of things that my company, lots of other companies are doing to enable exactly that. Make it accessible to anyone.
I think real world object capture is another one. So how do you, using a phone or glasses or something, how do you scan an object and then just import that into your metaverse?
Yeah.
And so I know Epic's doing a lot of work,
Yep.
Sketchfab and other things around. How do you enable like creative non-coders to also work in this? Adobe's doing really interesting work here.
It can't
We're doing
just be
some
C++
with them.
developers that are
Yeah,
doing it.
exactly.
Great point.
Exactly.
Great point. Well, we are out of time back here on the sign that's flashing. So first of all, please join me in thanking our panelists. Wonderful discussion. Really appreciate it. Thanks to all of you for participating, for asking the questions. We really appreciate it. Last point, again, grab a ticket before you leave the room, and please come back tonight at 5:30. Our speakers will be there, both from this panel and from some others. So a great opportunity to further engage and ask additional questions. So thanks again. Thank all of you. Really appreciate it. Enjoy the rest of the day. Great job.